Good morning. So in the last class, we already discussed about the magnetic effect of the electric current. So that is, we already studied about the Oersted experiment. What does an Oersted experiment says? When a conductor is carrying a current, around the conductor there must be the presence of the magnetic field. So we need to study about what is the meaning of the magnetic field, and also what is the meaning of that magnetic field lines, and also what is the magnetic field. Let us understand clearly. Okay. Here we have a magnetic field. Let us discuss about a simple experiment here. We have one cardboard here, and here is the conductor. Just this conductor AB is just passed through this the center of this cardboard, and terminal A and also the B is connected to what? A battery. Here is the battery. One is the positive, and also this side is the negative. When I switch it on, the current is just the pass-through lines. This is the flow of current, because here is the positive, this side is the negative, the positive direction. So it is a pass through the positive direction like this, and then it starts moving. Take one magnetic needle. Okay, magnetic needle. So it has a if you keep the magnetic needle anywhere, which always shows the north and also south direction. Keep a magnetic needle here, anywhere. Okay. So it is just showing the direction. Then if you keep the magnetic needle somewhere here, okay, it will never shows any direction at all. It will just shows the the north and also south. Keep a magnetic needle here. It will show the north and also south direction. If you keep here, it will shows the direction. It means that this is termed as the magnetic field around the conductor, which is carrying current. So then what is the meaning thereby a magnetic field? As you go on increasing this particular current, the magnetic field is also increases. As you go on decreasing this particular current, so the magnetic field is also what happens here? It decreases. So it means that, let us consider like this. Here we have a conductor carries the current I. So around this conductor, there must be a presence of the magnetic field. So what is the magnetic field then? It is a region or a space around a magnet, or what I can able to say, the conductor carrying the current. So where there is a magnetic force which is presence. There is a presence of a magnetic force. This is what we termed as the magnetic field. So magnetic field is a region or a space around a magnet, or what we can call it as a conductor which is carrying the current, where there is a magnetic force acts. So that is what we termed as a magnetic field. Now let us pass on to the magnetic field lines. What is present in the magnetic field? There must be a presence of the magnetic field lines. As you know, around any kind of a bar magnet or any horseshoe magnet, okay, here is the north and this side is the south, means around this there is a presence of the magnetic field lines. Okay. It looks like it will start from the north and ends in the south direction. In the same manner, for this conductor which is carrying a current also, there must be a presence of the magnetic field lines. Okay. So then what is the magnetic field line? It is an imaginary. You can't able to see this particular the field lines. Okay. But because of that magnetic force, we can come to know that there is a presence of something that is termed as what here, the magnetic field lines. Now we have a magnetic field lines around this. Okay, it's an imaginary the lines which is drawn around a what? Conductor carrying a what here? Current. Or we can say the magnet. Okay, that is what we termed as a what here? The magnetic field lines. So we have some properties of magnetic field lines. So the first and foremost property is that it will never intersect. So the magnetic field lines not intersect. It never intersect each other. So it is not possible the magnetic field lines like this and it is in this manner. Okay. Because it has only one direction, you already know that. Okay. A single pole is never possible. And then secondly is that where there is a more and more magnetic field lines which is present, then it is termed as what here? The strong, what is present over there? There must be a presence of what here? The strong magnetic field. And where there is a very less the magnetic field lines are there, it is termed as what here? Less magnetic field. It will gives a what here? Strong and also strong and we can say weak magnetic field. Weak magnetic field. So where there is a more and more magnetic fields or magnetic field lines are there, we can say it is a strong magnetic field. Where there is a less magnetic field lines are there, then we can call it as an what here? So that is called weak magnetic field. So you just consider here is an anywhere you can put a one point and then draw a line like this. It will always shows the what here? The direction of the water, the magnetic field. Okay. So the field is tangent to the what here? Magnetic field. The field, magnetic field, what I say? Field is tangent to the what here? To the magnetic field. Okay. Field is always what here? Tangent. So these are all we can consider as the properties of what? The magnetic field lines. And it will forms a continuous loop. Okay, it will forms a what here? Continuous loop is forms. So look at this. So this is in a magnet it will forms a continuous loop in this manner. So in the same manner. So for here also the conductor the carrying a current is also forms a what here? The loop. These are all some properties of what here the magnetic field lines. Now what is the direction of the magnetic field? So let us call it as the magnetic field in B. What is the direction of this magnetic field? So we have one rule to find the direction of the what here? The magnetic field. So that is what we term as an right hand rule we can say, or we can say thumb rule. Okay. This term doesn't want here, right hand thumb. Now we just here is the conductor AB. The current is flowing in this direction. Then what is the magnetic field? I had written the direction here. Okay, direction of the magnetic field is in this way. If a current is flowing in an opposite direction like this, in this manner the current is flowing. Okay, like this. Then what about the magnetic field here? It is an opposite direction. Do you agree? So how to recognize this? So there is one rule is there that is termed as a what here? Right hand thumb rule. That's the right hand. Okay. Hold a conductor. Let us imagine this is a conductor. Imagine you are holding a conductor carrying a water, the current. So I am holding the conductor like this. The thumb is outward. This thumb is what here? Outward. Okay, just hold the conductor like this. A thumb shows the direction of the current. Direction of the current. Let us say the first diagram here. This is the direction of the current, I. Okay, this is the direction of the current. It shows the direction of the current. Then you say all other fingers. So here, all other fingers shows what here? Direction of the magnetic field. So just I will write this. The direction of the magnetic field is B. Look at this. So this is all in this direction. It is flowing in this direction. So please see here the diagram here also. So it is the same as this one. So it is revolving around like this. This is the thumb. So I am changing the direction of flow of water, the current. Next, what happens? So it is in this manner it happens. Do you agree with me? Okay, the current is flowing downwards like this. If the current is flowing vertically upwards, here is vertically downwards. Now, please look at this. Compare these two things. The current is flowing downwards now. Then what happens? The direction of the magnetic field is like this. So high. So this is the direction I current, and here we have what here? B is nothing but a what here? Magnetic. So I think you might have understood this thing. What is the right hand thumb rule? How to state this one? Okay. A right hand thumb rule states that hold a conductor in your right hand, the thumb is outward. The thumb shows the direction of the current, and all other fingers shows the what here? The direction of the what here? Magnetic field. Okay, this is termed as what here? Right hand thumb rule. Thank you for watching this video. Thank you very much.